Hello students, now here in this video we have to see the methods of studying correlation. Before going towards that, let me give one note to you. Correlation is denoted by R. Remember this, correlation is denoted by R. So now let's see methods of studying correlation. Methods of studying correlation. So first method, scatter diagram. Second, Carl Pearson's coefficient of correlation. Carl Pearson's coefficient of correlation. So let me explain first scatter diagram. Scatter diagram. Now what does this method? Obviously it is a diagram, means we have to plot a graph. As we are learning about the relationship between two variables, so we can easily plot them in our xy plane. So in order to visualize the correlation between two variables, the first step is scatter diagram. First step is scatter diagram. So now here let xi, yi, here let xi, yi, I goes from 1 to n, be a bivariate data. Be a bivariate data on two variables x and y. On two variables x and y. Let the values of the variable x and y, values of the variables x and y be plotted along the x-axis and y-axis. Plotted along the x-axis and y-axis in xy plane. Okay, by choosing obviously suitable scale. Choosing a suitable scale so that it measures the range of the data. Range of the data of both the variables under consideration. Then corresponding to every order pair every ordered pair xi yi, there corresponds a point or a dot in the xy plane, and the diagram of dots. So obtained is called a scatter diagram. It may indicate both degree and the type of correlation. So it's a very simple method. Whatever data we have of two variables, we will consider one as x variable and other as y variable, and we will plot the graph of them and look at how does the graph occur. The dotted graph will give us, if it will be increasing, then there will be a positive correlation. If it will be decreasing, then negative correlation. And if neither increasing nor decreasing and there is no relation, that will be a zero correlation. Fine. Now, but every time this method doesn't work, means it has some merits as well as demerits. So let's see what are the merits and demerits of this scatter diagram. So merits and demerits. So let's see the merits first. Merits. What are the merits of it? First, it is the simplest method. Of studying correlation. It is the simplest method of studying correlation. It is easy to understand. Third, it is not influenced by, means affected by, extreme values. Now, this one have some demerits also, as it is not applicable everywhere, means it does not give numerical measure, numerical value or the measure in how much extent does, what was the degree there of correlation. Second, it is a subjective method. It is a subjective method. Okay, and one more, as it is not applicable, so it cannot be applied to qualitative data. It is applicable for quantitative data only, while it is not applicable for qualitative data. Now, from this, there are some graphs we can give. Now, perfect positive correlation. What is perfect? Further, perfect positive, let me write in detail, positive correlation. What was the graph here? Perfect positive correlation. Here, the scatter diagram occurs as in this direction, means clearly in direct proportion. It runs from lower left hand corner to upper right hand corner, and here r is equal to what? 1. Keep in mind this thing. This is x axis, y axis and origin. You can denote this much, it is enough. Perfect positive correlation. Then other one, perfect negative correlation. Perfect negative correlation. So how does it? Here obviously what happened? The graph decreases, so it will be decreases as such. Upper left corner to lower right corner. Here r is equal to what? -1. Remember this. R is -1. Similarly, other high degree positive correlation, high degree negative correlation, again low degree positive correlation, low degree negative correlation, and no relation. We will see the graphs of them or the scatter diagram for them. So, other one is high degree positive correlation. What was the graph or the scatter diagram? It is as such, high degree positive correlation. Similarly, high degree negative correlation. How does the scatter diagram? You may have just this one now. It will be as such. Such a thing will be there. The next, low degree positive correlation. Low degree positive correlation. Then how does this? It will be as such. Now low degree negative correlation. Obviously it will be as such. Okay. Then one more is left, no correlation. No means a zero correlation or the no correlation. So the scatter diagram for that, no or zero correlation. You should note the difference between the scatter diagram. Be careful for that. Now here it will be simply as such, neither any direction, neither increasing nor decreasing, simply dotted. It will be as such. Here r is equal to 0. Remember this. Okay. Now this is about the scatter diagram. Now further we have to go for Carl Pearson's coefficient of correlation or the product moment coefficient of correlation. But before going towards that, let me revise something from previous semester. Already we have learned covariance. Covariance is what? The arithmetic mean of product of deviations of the observed values. Okay. So we need that one. Let's see the definition of it. If xi yi I goes, I will be 1, 2, so on up to what? N are bivariate data on xy, then covariance between x and y. Covariance between x and y is defined as the arithmetic mean, of products of deviations, of the observed values of x and y from their respective means, and is denoted by covariance between x and y. What is it? Covariance between x and y is what? Summation I goes from 1 to n, product of deviations from their means. yi minus y bar. It is arithmetic mean of product of deviations from their means upon n, because n observations are there, where what is x bar? X bar is obviously summation xi, I goes from 1 to n upon n. What is y bar? Y bar is summation yi, I goes from 1 to n upon n. Okay, now let's simplify it so that we can easily calculate this one. No need to obtain these deviations on. Let's see what happened. So let's simplify it for some extent. Some covariance x and y. Let me write this 1 upon n aside. It is summation I goes from 1 to n is applicable for this product. So xi minus x bar and yi minus y bar. Now let's take the product of this bracket. So 1 upon n summation I goes from 1 to n. Now what does this product? It is xi yi minus xi y bar minus yi x bar plus x bar y bar. This will be a product. Now this summation will be applicable for this wherever I occurs. Fine. Now if I will apply summation here, it doesn't affect. It will be 1 upon n. Okay, 1 upon n. And this 1 upon n is multiple to the whole sum. Here we can give such a bracket also. Fine. So I can write it is summation xi yi, I goes from 1 to n minus summation xi y bar, I goes from 1 to n minus summation yi x bar, I goes from 1 to n plus summation x bar y bar, I goes from 1 to n. Fine. Now this 1 upon n, let's use it. This will be multiplied by this. So 1 upon n summation xi yi, I goes from 1 to n minus here 1 upon n summation xi y bar, I goes from 1 to n. I can take this y bar aside. If we see this part is nothing but this one. Look at it. It can be written as 1 upon n times this one. So it is x bar minus this y bar is independent on I. That's why we can take it aside. Similarly, 1 upon n summation yi x bar, I goes from 1 to n. If we look for this, it is y bar plus. Now the both of them are independent, so here simply 1 is added how many times? N times. So summation is this, so it is an addition, so it will give us n x bar y bar. But sorry, here one more thing, 1 upon n into n will occur, because this n from this summation and this 1 upon n is this one, we have been multiplied by it. So here we get 1 upon n summation xi yi, obviously I from 1 to n. Here as I have explained, it is x bar y bar. This is also y bar x bar, sign remains same. Here this n get cancelled, so plus x bar y bar. So this get cancelled. They have opposite sign, so it is get cancelled. So what is it? 1 upon n summation xi yi, I goes from 1 to n minus x bar y bar. So we have This is a very simple formula to calculate covariance between x and y. Now let's see few notes on covariance. What we have seen, covariance between x and y is what? 1 by n summation xi yi. I goes from 1 to n minus x bar y bar. So here let's see few notes on it. Note first, covariance may be negative, 0 or positive. Depending on the nature of correlation. Between the variables. Second note, covariance between x and y is same as covariance between y and x also, because if we change the product will remains same. Then covariance between x and x, if I put yi as xi here, so it will be xi square, and this is minus x bar square, so it is nothing but variance of x. Similarly, covariance between y and y will be variance of y. Okay, it will be same, so I won't write that. Again, covariance between x and y is what? 1 upon n summation xi minus x bar into yi. I goes from 1 to n as y bar summation xi minus x bar, if this one is what? 0, or as xi minus x bar, or as not this one, while this summation, or as this summation is also 0. Okay, I goes from 1 to n. Fine. And from this we can write also covariance between x and y is what? 1 upon n summation xi into yi minus y bar. I goes from 1 to n as x bar into summation yi minus y bar. I goes from 1 to n will be 0, or as summation yi minus y bar, I goes from 1 to n is what? 0. One more note, covariance is an absolute measure. Covariance is an absolute measure. It is an absolute measure. So now here we will stop for this video. In next video we will see Karl Pearson's coefficient of correlation. Thank you.